let's put our newfound knowledge of box plots into action. We want to look at the following box plot, which shows the percent of teachers that are under 30 years old by type of school for a random sample of countries in 2020. So primary school, secondary school, tertiary schools. All right, so describe the shape of the distribution for primary schools. So let's look at primary schools. So the box is a little bigger on the right, and the whisker is a little bigger on the right. So not tons, but it is definitely positively skewed. It's skewed right. If you want to make a note why, it's because the box and the whisker are larger on the right. Okay, so what's the best measure of center and spread for primary schools? Okay, well, when a data set is skewed like this, we've learned that the resistant measures to skewing are the median, right? So for center, we would pick the median. And for spread, we would learn our new one, which we learned in section 3.4, which is the IQR, because both of those are resistant to outliers and skewing. Resistant. We actually don't have any outliers for primary schools because there's no dots, but it's resistant to the pull of skewing, right, to the skew data. All right, what is the first quartile for secondary schools? All right, so secondary schools is this box plot right here. So the first quartile is right there, that first line. So it's just a touch above 6, right? So this is 4, this is 8. So this number must be 6, and we're literally a hair's breadth above it. So maybe 6.1%, something like that. So that'd be 6.1%. And then if you remember what this is 6.1% of secondary school teachers are under, it didn't ask for this. You could just say 6.1%, but just so you understand what's happening, it's percent of secondary school teachers are under 30. Right? All right, which type of school has outliers? Well, the outliers are the dots. So the type of school that's outliers that has outliers is tertiary, some other type of school outside of the main primary or secondary. What is the maximum value for tertiary schools? Okay, so when you look at tertiary, you might think it's this whisker, but it's not. You have to keep going all the way out here. So this is 28. You figure this is 30, this line right here. So we're just right around 29, maybe a little bit under 29. So I'm going to go 29. About 29%. All right, what percent of primary schools had less than 12.2% of teachers under 30? Okay, so let's look at the primary schools, and we have to figure out where 12.2 is. So here's primary up here. 12.2 is right there, right? That's that middle line. So this is 12.2. But remember, that's the median, and the median is the 50th percentile. There's 25% in this whisker right here. 25% of all the schools are here, and then another 25% are right here. So together that makes 50%. All right. What percent of secondary schools had more than 12.7%? Okay, so secondary schools is right here. That's the 12.7 right here. So this is 12.7, which must be Q3, right? Because it's the edge of that box. So the percentage above that, the percentage more than that, would be this whisker over here, and that whisker is 25%. So the percentage that's more than would be 25%. If I had asked for less than, it would have been 75. All right, which type of school had the lowest average? Now remember, average for us we measured by the median, right? The median is our best measure of center. So we want to look at the three and look for the median lines. So that one's about 12.2. This one's about 8.8. This one right here, right? Tertiary. Tertiary is the lowest. So, all right, which type of school had the largest range? Well, the range is from the min to the max. Okay, so that's from the tip of one end to the tip of the other, and that might mean a dot, right? So primary is from min, right over here, to max over here, right? That's the primary, which is really big, way bigger than secondary, right? Min and max are secondary. But look at the tertiary. The min is just a touch lower, but all the way over here, the max is a dot that's higher than that whisker. So that min to max is the biggest one. That's the largest min to max out there, just by a little bit, right? So that outlier dot counts as part of your min to max range. So also tertiary. Which type of school had the largest IQR? Well, the IQR is from Q1 to Q3. It's the box. So what we're really asking is which one had the largest box, the widest box. Okay, so let's look. The width of the box, this one, this primary one, that's the biggest from lowest to highest. So that would be our answer for that one. Okay, so let's put everything we've learned about shape and center and spread and all of that into one table. Now, there are three main shapes we've learned so far: the skewed left shape, the symmetric shape, and the skewed right shape. Now, we learned back in section 3.1 that when it's skewed left, that will mean that your mean is less than your median. So if I put these in here, the mean will be right here. The mean gets pulled to the tail, and the median will be right here because the median resists that. When it's symmetric, they're basically at the same spot. So the mean and the median are basically on top of each other or very, very close to each other, and so it's fine, right? So mean and median are together. And when it's skewed right, the mean again is pulled towards the tail. So this would be the mean right here, and this other line right here would be the median. Right? So when it's skewed left, the mean is less than the median. When it's symmetric, they're basically the same. And when it's skewed right, the mean is greater than the median. Now, how does this look in a box plot? Well, basically, very similarly to that. It skewed left, it could have a longer whisker and a longer box on the left, or it could have outlier dots and then a whisker, and that. If they're symmetric, they'll basically be the same on both sides for all intents and purposes. And there could be outlier dots and then a box and whisker and then more outlier dots, but it basically is the same. And skewed right would have that longer piece on the right. Sometimes the longer box, sometimes the longer whisker, sometimes both. Things like that. All right, now let's reiterate. How can we tell that it's skewed left? Just from the mean and the median. So the mean is less than the median. Actually, let me write it this way. Let me write it with my colors from up above. So the mean, which is orange, is less than the median. That's what this symbol means, right? This symbol means less than. Actually, I changed how I rewrote that because I want to be able to write it like this. Okay, so then this one would be the mean is approximately the median. They're basically the same, so we do an approximation symbol, which looks like a squiggly equals, but they're very similar. And how similar is similar enough is kind of a judgment call that you have to make, right? This is not going to be a hard and fast rule. It's a judgment call that you make based on the data set, right? How big the numbers are in the data set. Is it close enough to be considered that? That's also sometimes why you want to have a graph to kind of back yourself up. And then if it's skewed right, the mean is larger than the median, or greater than, or more than the median. And I always think of it in terms of the mean first, because the mean is the one that gets pulled towards the tail. So it gets pulled to one side or the other. All right, now if it's skewed, and we just saw this on the previous page, the better measure of center, if it's skewed left or skewed right, center, which is also known as average or central tendency, would be the median, because it resists skewing and resists outliers. Same thing over here, right? If it's skewed right, the better choice is the median, right? Because the median resists skewing and outliers. Now, if the graph is symmetric, then you're better off with the mean. And that's because the mean uses all the data sets, and it's not as, well, it uses all the data points. And resistance is not needed because it's symmetric. Right? All the data points go into making the mean, right? You use every single one of them, whereas the median's a little bit more of a cutoff. It doesn't quite use the points. It kind of uses how many are below it and above it. Now, for the same reasons, the better measure of spread, if it's skewed, is IQR. And again, the reasoning is the same, right? So I'm just going to say because same as above. Well, actually, I think I like my arrow. I'm just going to leave my arrow there, right? Same reasons. Same thing if it's skewed right. If it's skewed right, IQR is best. And again, because of what I wrote right there, right? Because it's resistant to the outliers. Oh, maybe that's a better place to put the because, right? So because of that. And if it's symmetric, well, then if it's symmetric, we'd rather have something that actually uses all the data points. The IQRs don't. They're not really fulsomely using the whole data set. So if you have a data set symmetric, then you're better off with the standard deviation, right? The standard deviation uses all the data points. So if it's symmetric and you don't need resistance, then you're great with the standard deviation, right? So you use the median and IQRs when you need resistance, right? Resistance to outliers. And you use the mean and the standard deviation when you don't need resistance and you want to use all your data. So later on in the course, when you're asked to describe a distribution and give the shape, the center, and the spread, this is kind of what we're getting at, right? So the shape would be one of these three channels, skewed left, skewed right, or symmetric, right? And then what's the better measure of center? Well, if it's symmetric, you're better off with the mean and the standard deviation. If it's skewed, either left or right, you're better off with the median and the IQR. That's what the table is showing us.